scientific notation. So this is the basic way that we describe our numbers. We simplify it so that we can write really, really big numbers or really, really small numbers here. So the first thing is, here's just an example of it. 1.2 times 10 to the negative fifth. So we're going to break this down to a couple parts to kind of help us understand what's going on here. So the first thing we're looking at is this number on the left before the multiplication sign. That is our base number. This base number right here is always a number 1 through 10, not inclusive of 10, so really 1 through 9 here. That goes in the ones place. So that's the spot right before the decimal place. Any part of it then goes after the decimal, so we can just throw any numbers that are still in it after the decimal. And then we're going to go ahead and multiply it by some factor of 10. And that factor of 10 is that exponent right up here. So the exponent multiplies or divides base number by a factor of 10. A negative would go ahead and be dividing by that factor, right? So if we go back to our algebra days, 10 to the negative fifth is the same as 1 over 10 to the fifth. So that's going to be 1 over, okay, and I have 1, 2, 3, 4, 5 zeros here. I had an extra. I got rid of it with that text box there, okay. Now, if we multiply, if it's a positive number, then it's just multiplying by 10 to the fifth, right? So that's 10 times 10 times 10 times 10 times 10, 10 to the fifth there, 100,000. So really, these are going to get the same answers. It's just kind of going back and forth and writing it with this base unit here, and then always by the power, our base 10 to some exponent here. So just to give you a few examples of this, if I have these four numbers here, the first step we're always going to do is we're going to find the base number to this, right? So I want the first non-zero number. So in this case, that's a 5, 3. The first non-zero would be 4. In this case, it'd be 6. All of these will always be in the ones place, all right? So I'm going to put this as 5 point, and then whatever is left over, I keep 5.2314 after the decimal. This one, it's already here, right? So I'd keep it right where it is, 3.2. 4.28, right? So the 4 is in the one spot. That's where I need it. And then I keep the 2.8. And this one, 6.02. Now, I really don't care about, I could, but I really don't care about these zeros. That's not going to change the number at all. But I need to keep that 2 right there. So the first part is always just getting our base right here. The next part is then how many times do we have to move the decimal to get to that point? So my decimal is right here. If we don't see it, it's always after that last number. And I need to move it to get it so that it's right behind the 5. So that's 1, 2, 3, 4 right there. 4 spots there. And then I want to say, is this number right here bigger than or less than 1? Is it bigger than 1 or smaller than 1? Well, this one's bigger, so I know that this should be a positive number. If you can keep that in your head, that's an easy way to think about this. Is if my number is bigger than 1, it's always going to be a positive exponent here. If it's less than 1, so smaller, so 1 to 0, then it will be a negative exponent here. So this one's bigger, so it's going to be positive, and I had to move the decimal spot 4 times. In this one, 3.2, right? It's in that one spot. I'm happy with that, and I don't even need to move the decimal. So that's 10 to the 0th power. All right, if we think for a second here, remember, 10 to the 0th power is equal to 1. And anything to the 0th power is actually equal to 1. So this still checks out. That's equal to 1. 1 times 3.2, that's going to give me 3.2, my original. In this case, if I were to multiply this out, right, 10 times 10 times 10 times 10, that's 10,000. Well, 10,000 times 5.2314 gives me 52,314. So I'm not really changing the number. I'm just writing it in a different way. This one, right, I have 4.28. Well, how many times do I have to move the decimal? 1, 2, 3, 4, 5 times, right? I need it behind the 4. Not in front, but behind. So that makes it 5. And this number is definitely smaller than 1. So I need this to be a negative 5 here because I want a smaller version of it. So I'm moving it negative 5 spot. This one, I moved it 1, 2, 3, 4, 5, 6, 7, 8. So I have my base times the power of 10 to the 8 spots I moved, and positive because it's bigger than 1. So if we look at a couple examples here, okay, I would need to get my base unit. So my first number I come to is 1. So I'm going to have 1.3, and I need times see how many times I move it. 1, 2, 3, 4, 5. Okay, so that should be 1.3 times 10 to the, and I moved it 5 times, and this is smaller than 1, so this should be to the negative 5th. Okay, and that's what I have right here, 1.3 times 10 to the negative fifth. Then I have 130,000, right? And I put that, so I still have 1.3. That's my base here because that's my first number. And then how many times do I move this decimal? So the decimal would be right here at the last number if we don't see it. 1, 2, 3, 4, 5. So that's going to be times 10 to the fifth right here, 1.3 times 10 to the fifth. It's bigger than 1, so it's definitely a positive integer. The next one I have is 2.76. In this case, I'm in scientific notation. I want to take it to standard notation. Well, remember, we just said if it's bigger than 1, it's going to be a positive exponent. Well, this is a positive exponent, so this has to be larger than 1, so we need to make this number bigger. So in order to make it bigger, I need to move the decimal to the right. If I moved it to the left, it'd make it a lot smaller, but I want to make it bigger because this is a positive integer right here. So it was right here, and I'm going to move it 4 spots over. 1, 2, 3, 4. So it doesn't necessarily say how many zeros, right? It's just saying how many times I'm moving the decimal. So 4 times to the right here because it needs to be bigger because it's a positive exponent. But in this case, it's a negative exponent. So this number needs to become smaller, right? So how many spots am I going to move it? I look at my exponent. That's 3. It's negative. So I need to make this smaller. So I'm going to move it to the left. 1, 2, and 3.